The topic is Jacobian. Jacobian जिसको हम पार्शियल डेरिवेटिव में यूज करते हैं. If we have three functions f1, f2, f3 of x, y and z, then determinant of del f1 by del x, del f1 over del y and del f1 over del z. And here second function is f2, del f2 by del x, del f2 by del y and del f2 by del z. And third function is f3. We write del f3 by del x, del f3 by del y and del f3 by del z. Its determinant is known as Jacobian. Jacobian. So finally we have to find just the partial derivative of f1, partial derivative of f2 and partial derivative of f3 with respect to x, y and z. So let's take one question. The question is, find del fg of del xy, which is also known as j of xy. If f is equals to x square minus x and g is equals to x square y square plus x plus y. So according to Jacobian formula, we have to find del f over del x, partial derivative of f function with respect to x. With respect to x means we take y constant, this is 2x minus 1, and del f over del y, del f over del y, partial derivative of f function with respect to y. Because of there is no y, this is only x, and x treated as constant, that will be 0. Again, now del g over del x, partial derivative of g function with respect to x, that will be x square. X square, derivative of x square is 2x, y square is constant, plus x is constant, x is variable, derivative of x is 1, plus y is constant and derivative of y is 0. Finally, this becomes 2x y square plus 1. And partial derivative of g with respect to y. Partial derivative of g with respect to y. Now x will be constant. This function is constant. So x square constant derivative of y square is 2y, x is constant plus 0, and derivative of y is 1. So this is 2x square y, 2x square y plus 1 plus 1. Now we put it in Jacobian formation. We put in Jacobian formation, and Jacobian formation is j of xy. J of xy is equal to determinant of del f over del x, del f over del y, del g over del x, and del g over del y. This is determinant. Del f over del x, del f over del x is 2x minus 1, 2x minus 1. Del f over del y is 0. Del g over del x is 2xy square, 2xy square plus 1. And del g over del y is equals to 2x square y, 2x square y plus 1, and whole determinant. Now we put the property of determinant. We find the determinant of this function. Determinant is by cross multiplying. Means 2x minus 1 multiply with 2x square y plus 1 minus 0 multiply with 2xy square plus 1. We get 2x multiply this 2x cube y, 2x multiply with 1, this is 2x minus 2x square y and minus 1. This become all 0. So final answer is 2x cube y minus 2x square y plus 2x. This is our answer. Done. Now let's take another example. Question is f of xy is equals to x plus y, comma x plus y whole square. Evaluate j of f xy. Let our g function is x plus y, and this is p function. Maybe p, we can take any name, p, g, or this is q function. So we take only p. This is x plus y whole square. First we find del g over del x, that is 1. Then del g over del y, this is also 1. And del p over del x, that is 2 and x plus y. Del p over del y, this is also 2x plus y. Now Jacobian j of f xy is equals to j of f xy will be del g over del x, del g over del y, del p over del x, and del p over del y. This is del g over del x is what? we got it 1, then we got it 1. This is 2 into x plus y, and this is 2 into x plus y. We can put a property of determinant also. We can put a property of determinant also by taking 2 into x plus y, taking common, and this will be 1, 1, 1, 1. The property of determinant is that if there is any 2 row or any 2 column is identically same, then the determinant will be 0. So here determinant will be 0. Or in other case, we can find it. This is by cross multiplication. 1 into 2 into x plus y minus 1 into 2 into x plus y. This is all same, and this also becomes 0. So we can use another method, that is direct determinant. Thus the Jacobian is 0. Let's take another example. Next example is f of xy is equals to x square plus y square, comma tan inverse y by x. Find jf on 1, 2. We talk about it later. So that this is our g function and this is our p function. We can take it g or p. Also we can take it f1 function, f2 function. Let this is f1 function. F1 function is x square plus y square. X square plus y square, and f2 function is equals to tan inverse y by x. F2 function is equal to tan inverse y by x. First, del f1 over del x, partial derivative of f1 with respect to x. So, because of this is the function of root, and direct derivative of function of root is that we write 1 over 2 into same function. Same function is x square plus y square. And now the derivative of this will be 2x plus 0. 2x plus 0. All this become cancelling 2. We get only x over x square plus y square root, and del f1 over del y, partial derivative of f1 with respect to y. This will be 1 over same derivative of function of root will be 2, right, same function x square plus y square. Then derivative of internal part, that is x square plus y square. X square is constant, so this is 0, and derivative of y square is 2y. And cancelling 2, we got y over x square plus y square root. This is the partial derivative of f1 with respect to x and with respect to y. In respect of f2 function, we find del f2 over del x. Partial derivative of f2 with respect to x, we write tan inverse. Derivative of tan inverse x is 1 over 1 plus x square. Derivative of tan inverse x is 1 over 1 plus x square. So x is here, y by x whole square. And del by del x, again derivative of y by x, This will be x square over x square plus y square. By solving it, we got it. And derivative of y is constant. Derivative of 1 by x is minus 1 by x square. So whole becomes cancelling x square, that is minus y over x square plus y square. This is the derivative. And del f2 over del y. Now the partial derivative of f2 function with respect to y will be same like this here. 1 over 1 plus y by x whole square, and del by del y of y by x. That is, this is the solution of this is x square over x square plus y square, and this is derivative of y is 1, so we write only 1 by x. Here cancelling x, we got only x over x square plus y square. X over x square plus y square. So finally we got partial derivative of f1 with respect to x and y. Partial derivative of f2 function with respect to x and with respect to y. Now use Jacobian formula. J. We can write only J. J is equals to del f1 over del x, del f1 over del y, and del f2 over del x, and del f2 over del y. This is del f1 over del x is x over x square plus y square root, and del f1 over del y is equals to y over x square plus y square root. Del f2 over del x is minus y over x square plus y square, and del f2 over del y is x over x square plus y square. By cross multiplying x square over this have half power and this have 1 power. This have 1 power. 1 and a half is 1 and a half. So we write x square plus y square, power is 3 by 2. 1 and a half is 3 by 2. Minus this minus and this minus becomes plus. Now this minus become plus. So we write y square over same procedure, x square plus y square all this to power 3 by 2. We can solve it also. We can solve it. We can solve it, and solution will be x square plus y square over x square plus y square, power is 3 by 2. This have power 1, this is 3 by 2. Cancelling 1 power here, we get only 1 over x square plus y square, power is 1 by 2. So we have to find J of f on j of f on 1 and 2 means we have to put x is equals to 1 and y is equals to 2. Y is equals to 2. So j of f 1 2 is equals to put x is equals to 1, 1 square is 1, and y is equals to 2 square is 4, and 1 by 2, that is 1 by root 5. So our answer is 1 by root 5 is our required answer.